So let's have a very quick discussion on debugging. So I have quite a number slides on it, and the bottom line is that you should not do it. So I will kind of quit this. Go away. Let's do this. Okay, so yeah, so Haskell is really difficult to debug, and there are many reasons why. The biggest reason is that it's a lazy language. So not everything is evaluated the way you think it is and when it is. So it's evaluated in a lazy way. So often things are kind of evaluated out of sequence and they are kind of confusing. It's very declarative, and you cannot squeeze in print line statements like in your code, right? So I sort of recommend that you kind of doing what you should do. You should use doc tests. So if you want to understand how your code is working, just use a lot of doc tests. So my function, given these arguments, should give those outputs, right? If your doc tests fail, you know something is not quite right? So on the project level, using unit tests and doc tests is great, right? But on the individual function level, you cannot really sort of do this because you wrote a doc test, you wrote your function, your doc tests fail, and you don't know why. You don't know why your function is wrong, right? So on the individual function, knowing that it's wrong because the doc tests fail, you still need to do some things. So then I recommend using GHCI. So try to extract the minimum amount of stuff that you need from your function and play with it in GHCI, right? So then that's what I do. Like I often do it in the lecture as well. I just cut some part of it and try to see if I'm getting what I think I'm getting, right? So use GHCI. And then for some things, you just have to stare at the code. You just have to like try to think like what the code is doing, right? In your head. There is no way around it. Like you have to train your ability to read code and to be able to reason in your head what the code is doing, right? We sometimes get lazy and we say, yeah, I don't care like what the code is doing. Like I just squeeze in print line statements and then I know what this code is doing because I can see. But that's a very handicapped way. Like you really need to think. But then again, like as I said, it's really difficult to debugging in Haskell. And I personally don't do it. Like if I get a hard problem, I have a bug in my function. It doesn't happen often, but it does happen. And then I try to decompose it into very small functions and kind of write doc tests for those very, very small functions. And then I kind of construct the bigger thing afterwards. So I'm kind of trying to do it like without the debugging. But you can say, yeah, if you really, really need to do debugging, go, rule number one, avoid debugging. But you can say, yeah, what I really, really have to do it. Like I really cannot understand it, and I have to put some print line statements. Okay, so then there is a trick, and the trick is called trace. And the trace is inside debug trace, and you just import it. So you say import debug trace, and I will commit it to the I will show you the code and I will commit it into the repository to the lecture 5. The function is kind of funny. Like you have to like mentally like get yourself familiar with the function because the function takes a string and a value and it returns the value which you give it. So you pass string and a value to the function and it will return the second argument, right? So what does that mean? It means you can squeeze that function everywhere you're using some value, because then you will get a printout out of something. Like you can do whatever you want with the printout, but instead of saying A, you can say trace A, and then trace some string A, and it will give, like the program will work as expected because A is there, but it will have this extra text which will go on the screen, okay? So let's see an example. So in lecture 5, I added this import debug trace, and now we have a function which does the multiplication table like in a recursive way. And this is one way of doing it. And this is a recursive way of doing it. So this one is non-recursive. It uses a list comprehension, and that's what you should use. But how would you squeeze trace for that? It's like, yeah, this implementation is like really resistant to be able to be debugged, right? You sort of have to stare at it and sort of understand what's going on. But this one is a little bit better. Like this one has this table ni, and it iterates row by row, and I can squeeze trace a little bit. So originally that thing here was not here, right? It's just the empty list. So if I is bigger than n, we return an empty list. So now I can squeeze this trace and string and the empty list, and it will get me empty list in this place, right? And then I have table, and the table takes two arguments. It takes n and I plus 1. So the original code is like this. So the original code is table n. Yeah, this is the original code, right? And now I want to squeeze in, when this call is made, I want to print something for myself. And I'm doing this trace with the string, and I'm concatenating what is the current value of n and what is the current value of I. And I replace this n with this call here, right? So I have to still pass the n. So the n is the second argument to my trace, but the first argument is this expression, which prints me two things, the n and I, every time this is called, right? So now if I run it, I have 1, 2, 3, doing it for n3 and I1, 246, doing it for n3 and I2, and 369, doing it for n3 and I3. And then I got to the end of my recursion, right? Is that very helpful? I don't know, like it's not for me, but maybe there will be cases where squeezing in this trace will kind of help you to understand, like in a sequence, what's going on, right? But is it helpful for this line of code? Not so much. Like, what would you substitute? You can substitute this n with this call, but what would you ask? Like, what would you want to see? You will have some text and n, and then that's it, right? So I think you can use it, but I don't find myself a very good use cases where I really need to use it. And I usually solve my things by decomposing it, right? So I created this function called print table, and then in the main, we saying put string print table 3, right? So we kind of are calling it for this. And then the debugging is like done this way. So if I if I remove that trace, I will have 1, 2, 3, 2, 4, 6, 3, 6, 9. That's it. I will have this rectangular printout. But with the trace, I have those additional things printed when the value of n was needed. So when this value of n in this place was needed for this call, for this table call. So we can see, I can kind of remove the debugging and I can call the real thing. So now if I tag run, we're gonna get, I still got the empty line, but we don't have this debugging output for the lines anymore, right? You may find it useful. You may find the places where you want to inspect something on the fly and have those printouts, but I don't recommend doing debugging, and I do recommend doing kind of the decomposition into simpler things. If this function is too complicated for you, uh, kind of analyze it from the back. So what is this function doing? Okay, this function is defined here, right? And then if you are too confused what this is doing, take this into GHCI and start function by function and see like how it is composed, like what show is doing, what map show is doing, and so on, right? You have to sort of walk through, and GHCI will kind of help you. So yeah, so then you have this kind of capability with trace, and you can use it if you need to, but I try to avoid it, and I try to let me see. Yeah, I try to use the doc test and unit tests. So heavily using doc tests. Every time I'm declaring a new function, I'm writing doc tests first. I want to see like, if I call it with those arguments, what should I get back? What should I get back? What should I get back? Some edge cases. And then I'm writing it. And it's often wrong. Like it often doc tests fail, right? So it means my implementation is wrong, right? Most often the implementation is not compiling. The compiler complains, right? So then usually the best thing is to take it to GHCI and try to simplify it and kind of walk through it. Most of the time, if the compiler stops complaining, your function is perfect. Your function works, right? So most of the time you're fighting with the compiler. And then once the compiler is happy, the doc tests usually pass. But write the doc tests first. All right, that's it. Questions about debugging? We will come back to it. Like I will argue for non-debugging later a bit more, but for now, that's it.